I hope is it visible? Is
Yes,
my
it's
screen
visible.
visible? Yeah, thank you. Yeah, so the topic basically of this presentation is blockchain basics and beyond. Why I'm saying beyond, because we are going to discuss one of the blockchain-based applications, that is mobile crowd sensing, and we will see the implementation exposure of it as well. So the agenda of this presentation is like, first we will see that why blockchain is important, why we need to use blockchain, then the introduction to blockchain technology, and then we will see how does blockchain works, blockchain core and drive properties, and who basically makes the blockchain secure, and the use case, that is mobile crowd sensing system. So why blockchain is important? I'm just taking an example of international money transfer where several intermediaries, the sender one's bank and the receiver one's bank, which are on the different basically places and different countries. So initially, it's a long process. The sender has to fill the form in order to send the money to their local bank, and local bank then will transfer the fund to intermediaries, then intermediaries will transfer the fund to recipient bank, and then finally it will reach to the recipient, right? So this is a very long process for now, and it takes uh, like what would be the issues for this traditional way? So first one is high cost, and there are several intermediaries in between. They may charge you, and the slow transaction speed, like it may take few days to transfer the money. Lack of transparency, so basically it is completely centralized, so there is no transparency. There could be some access issues, security concerns, and regulatory burden, obviously, because we are transferring money from one country to another. So these are the issues with this international money transfer application. So how we can solve it, like blockchain, we will see, we can understand after seeing the blockchain properties that how blockchain can solve these issues. Another example of like web-based application, basically centralized web-based application. So this is how it works. So we have browser through which we access the application, and we at the back end we have server, right? And our front end code and back end code both will be residing on the server along with the databases, right? And this server is managed by the central authority, so which makes it very error prone, and there could be some security issues as well. So what could be the issues with this centralized web application architecture? One is the centralization of authority, obviously, because there is only one organization who is maintaining this whole server, right? So, and the second one is single point of failure. Third one is data integrity and security. We are not sure whether the authority is genuinely playing, or they may change the data, they may change the code, and there are several other possibilities that the central authority can do. And another point is there is no transparency and there is no auditability, and updation and maintenance cost and control is very difficult. So now we will see that how blockchain works, what is blockchain technology. So first thing, that it is not centralized. That is why one of the problem that we have in centralized system is the transparency, and the one we have seen, the single point of failure, that we don't have here, because blockchain is a peer-to-peer network. As we can see in this figure, so there are several nodes are showing, and all they are connected to each other, right? And there is no central authority who is controlling this network, peer-to-peer network, right? So that is why we call it centralized. And then each node must maintain a ledger, and ledger is nothing but a way to store the data, right? So this ledger is nothing but blocks which are connected to each other. So that makes it as a ledger, right? So, and this ledger is maintained by each node. So that is why we call it distributed. Like the data that we store over the blockchain will be having by each and every node. So the definition that we can say is blockchain is a decentralized distributed ledger technology that records transactions across multiple computers in a way that ensures the security, transparency, and immutability of the data. So now try to understand what the transaction is. So transaction is just a way to transmit the data across the network. So whatever data you transmit over the blockchain, so that will be stored in a way of transaction. So transaction has its own structure where your data will be stored along with other fields or parameters, right? And how the security is maintained, that we will see the transparency and immutability. Transparency is achieved because whatever we are doing over the blockchain, so that is publicly available. Anybody can see it, anybody can verify it. Immutability in the sense is whatever data you store over the blockchain, that cannot be changed. I mean, it is not possible. It is not feasible to change the data. Okay, so this is what in overall, this is what the definition of blockchain. So this is a ledger structure that we have. So ledger is nothing but multiple blocks are connected to each other. So and each block is nothing but a collection of transaction. So inside a block, we have blockchain block header, so which contains several fields like version, previous block hash, timestamp, and other information. And the second one is the transaction counter, how many transactions we have in that particular block, and the set of transactions, whatever transaction we are basically having in a particular block. So this is how they are connected to each other because of this previous block hash. We are storing in each block the hash of the previous block. So this is how they are connected to each other. Now, how does blockchain works? So initially, everything is basically done through the transaction. So let's say I'm a sender and I want to send something like I want to transfer money, I want to transfer some digital asset, or I want to execute a function inside a smart contract. So smart contract, we will see what is it. But for now, we just consider it as a code where we have written multiple functions. So when we do any of these action, so a transaction will be initiated, right? But before sending it to the blockchain network, we have to do something else. And what we have to do, we have to sign this transaction using our private key. So the sender will use their private key to sign the transaction, so which employs a digital signature to ensure the security, right? And then this transaction will be broadcasted over the blockchain network so that each and every node in the blockchain will basically have this. Now, so there are in some of the nodes will be basically treated differently. So they have some main roles in order to maintain the decentralization and the security. So those nodes we call like miners or validators, right? So what does they basically compile the transaction, they execute the transaction, and they keep some of the transaction into a block. So that depends on the block size. So and then verify them, and then they employ a consensus mechanism such as like proof of work, proof of stake, and delegated proof of stake. So there are so many consensus algorithms that have. So that depends on the which blockchain we are referring to. So according to it, they use different consensus mechanism. So now miners basically employ this consensus mechanism in order to decide that which node is going to add that block to the blockchain, right? So for instance, like if we talk about proof of work, so what we do in proof of work, each miner basically compete each other in order to solve a complex problem, hash-based complex problem. So the problem is like you need to make a hash, uh, and the difficulty of that finding the hash is like number of leading zeros. So that decides the difficulty of that complex basically puzzle. right? So based on that, they basically compete each other, and the one who find the correct hash or to find the correct hash in order to solve the puzzle, whoever first do that node will be basically adding the block to the blockchain, right? And the one who win, that miner will broadcast the block to the network so that every node in the blockchain can verify that block and can add that block to its own blockchain ledger. And the transaction confirmation is like the transaction receives further confirmation as more blocks are added to the chain, to the ledger. So which enhancing its immutability and security. So the core blockchain properties are like first one is decentralization. So decentralization means there is not a single authority who is maintaining the whole blockchain, right? So the very first point is decentralization, and it eliminates the need for a central authority. Second one is distributed nature. So we call it distributed because the data is shared across multiple nodes, right? So it is not like that if one node of that network is not working. So in that case, your blockchain will still work, right? And the third one is immutability. So immutability, once data is recorded, it cannot be altered, right? So it is very difficult to change. Let's say you are changing one particular block, right? So in order to make the blockchain perfectly work, you have to change the hash of all previous blocks so that it would be considered valid, and which is very difficult. So next is transparency. Transparency is like whatever we do over the blockchain, all the transactions, all the data are visible to every participant. And another property is pseudonymity. So in the blockchain, when we interact with the blockchain, the users interact with the pseudonym identity. So one pseudonym identity is basically associated with each blockchain user, through which that user will interact with the uh, blockchain, right? So there is no personal information attached with that particular identity or address. So that is why that they inherently provide we can say identity privacy at a certain extent until and unless your pseudonym identity is attached with your personal information. So there are certain derived properties that we have, like first one is trustlessness. So that means there is no need to have trust between the parties, right? And this is coming because of the core properties like decentralization. So there is not a single authority. Then permissionlessness. That means anyone can join the network, anyone can participate it, and if they want to exit, they can exit as well. Next one is programmability. That means we can write some program. We can write some program to implement our application logic so that we can basically run our application over the blockchain. Next is automation. So automation is like processes are executed automatically. That means you just need to create a transaction, and the execution part will be handled by the miners or validators. Next is tokenization. So that is one of the property of blockchain that we can basically create our own token, and assets can be represented as tokens. So the next one is ownership, and so this is what the digital ownership of the asset. Let's say I'm submitting some kind of data over the blockchain, so that will be associated with my pseudonym identity, so that we can say, okay, this data belongs to me. And next is traceability. Traceability is like anyone can trace whatever is happening over the blockchain. So anyone can find out that. So next is security. That is all derived from multiple core properties. Like security is coming from, you can say, consensus mechanism, then uh, because of decentralization, and then cryptography we use to ensure the security. of the blockchain. So next is who makes blockchain secure? So that is another question. So basically here we use cryptography in order to make blockchain secure. So what is cryptography? Cryptography is basically it is a technique for securing communication and data from unauthorized access. So it basically what it does, it encodes your original data and then send it so that nobody can read it, and the authorized person will can basically decode that data and can have the correct information. So the core function of cryptography includes like it provides confidentiality, it provides integrity, authentication, and non-replication. So in order to achieve these properties or functions, we do have different algorithms and different way to achieve this. So confidentiality is like ensures that only the intended recipient can access the information or data, right? Integrity is like data cannot be altered in transit or storage. Authentication is like verifying the identity of the node or the person who is involved in the communication. And non-repudiation means nobody can deny that I did not initiate that particular transaction. Okay, so these are the core functions of cryptography. Now, there are three types of cryptography. One is symmetric key cryptography, another one is asymmetric key cryptography, and the third one is hashing. So symmetric key cryptography is like, so there are algorithms like if I want to achieve confidentiality. So there are algorithms like EES and AES. So currently we are using AES. So the main important point here to understand is the security, the confidentiality that we achieve is through a key. And this key is used to encrypt the data, and the same key is used to decrypt the data. So if I want to send something to you, in that case, we both will share a key, and I will use that key to encrypt the data using AES algorithm. And you will use the same key to decrypt the encrypted data using the AES algorithm. So AES is having two parts. One is like encryption algorithm, and the second one is decryption algorithm, right? So the main point in this symmetric cryptography is that here we use the same key to encrypt the data and to decrypt the data. Okay. So the next is asymmetric key cryptography. So here we, instead of using a single key, we use two keys. That one key is used to encrypt the data and another one is used to decrypt the data. So here we use a pair of keys. So each pair is having two keys. One is we call public key and another one we call private key. So public key is the one that is publicly available. That means you can assume that this key is available with everyone, right? You can show it to anyone. But the private key is a secret key that you need to keep it secret in order to secure the communication, right? So like in this case, if I want to encrypt some data and send it to you, so in that case, what I will do, I will use the public key of the receiver in order to encrypt the data so that the receiver can use their own private key to decrypt that data. So that part is important. So that is through this we can achieve confidentiality. But like if I say that I want to achieve like authenticity, or I want to make a digital signature. So in that case, what we do, let's say I want to send you something with my digital signature along with that data that I'm sending to you. So in that case, what I will do, I will use my private key to basically encrypt the data, and then I will send it to you so that you can verify that this data is coming from me, right? Because you have the public key, you can decrypt that one and can verify that signature that I'm sending. right? And this verification will only be done when you have the corresponding public key with which I basically the pair one, right? It is not like that you are using public key of one key pair and the private key of another key pair. So you have to use the same key pair in order to make the signature and in order to verify the signature. Okay. And the third one is hashing. So hashing is what is a cryptographic function that takes arbitrary input size and it returns a fixed size string. So that fixed size string is known as hash, or we call it digest. So let's say you have 1 GB data or whatever size of that data is, right? So what you do, you perform a hashing algorithm over that data and you will get a fixed size string. So for example, there are several hashing algorithms like we have SHA 512, right? And we have MT5, but the one that is currently is in use, that is SHA 512 or SHA 256. So this 256 and 516 is highlighting that what is the size of the return hash or return digest. So if I am using SHA 256, that means the string that I will get in return must be of size 256. And in the same way, if I am using 512, and the size of the hash must be 512. And another property of this hashing is not reversible. I mean, if you make a hash with some data, so with this hash, you cannot get back the original data. So that is the main property of this. While you must have noticed that if I say that encryption or the symmetric cryptography or asymmetric cryptography, so these are reversible. Like I can encrypt it and then I can decrypt it, that encrypted data in order to get the original. But this is not the case with hashing, right? So now the use of cryptography in blockchain. So what kind of these types of cryptography we use in the blockchain? So here we use public key cryptography, which is nothing but asymmetric key cryptography, and the hashing. We use these two things. And in that particular asymmetric key cryptography, we use digital signatures, right? So for instance, let's say I am sending some data over the blockchain. So as I told earlier, that whenever we do something over the blockchain, first thing is we create a transaction, right? So that transaction must be signed by me and then I transfer it to the blockchain network. I broadcast it to the blockchain network, right? So in order to sign it, we need to use digital signature, right? So that any other node in the blockchain network can verify the signature using the public key of mine, right? So the algorithm that we use in like elliptic curve digital signature algorithm in Bitcoin and Ethereum in order to sign the transactions. So this is the first use that ensures that you can see what are the properties you can achieve here. First thing, you can achieve authenticity, that okay, that transaction is coming from the right person. And the second one is non-repudiation. If the transaction is signed by me, so I cannot deny that this is not signed by me, okay, because I have signed it using my private key, which is supposed to be only with me, right? And the hashing part that we use in order to ensure the immutability. So as we have seen earlier that the block structure, like block ledger, so each block is having the hash of its previous block, right? So that we are connecting each block to one another, right? So in that case, in order to find the hash of previous block, we are using hashing technique. And here we use SHA-256 in Bitcoin. And there is another algorithm that is KEC 256 in Ethereum. So the way could be different, but the ultimate objective of these algorithms are same. Okay, so this is what the introduction of blockchain technology, where we discuss like what is blockchain and what are the key components of blockchain, and we have seen the core properties of the blockchain, right? So I would like to again go back and will focus on these properties so that initially we discussed the drawbacks of centralization, right? So for the issues, what first one was that there is a central authority. So here in blockchain, if there is an issue of central of authority in any application, that we can solve using blockchain because there is no centralization, right? Next is single point of failure that we have in the centralization applications. So if you need in your application that the data must be stored in over multiple nodes and you don't want to have this single point of failure issue, in that case, we can use blockchain, right? And the third one is if you need immutability. Here in the centralized applications, we have seen that all the data, everything is and control of a single authority. So that can change anything. That can change the code, that can change the data, right? So in order to achieve this, that nobody can change the data, whatever you have stored. So that ensures this blockchain. And another one is transparency. So there in centralization applications, one of the major issues is transparency, which does not basically ensure trust among the users who are using that particular application. But in blockchain, due to this transparency, so we can have trust that nothing is going wrong over the blockchain. And another one is like pseudonymity is another advantage of blockchain, right? Okay, so that's it from the block introduction of blockchain part. Now we see, uh, okay, do we have some uh, some students here? If you have any doubt, I would be happy to take this. Otherwise, I will continue.
I think
Okay.
so. You can
That,
continue. It's clear for all who is here.
thank you. Yeah, thank you so much. Okay, so now we will see one of the application of blockchain technology, that is mobile crowd sensing. So first we need to understand what is it? What is mobile crowd sensing we are saying? So, so it is just, let me give you this in one line, that mobile crowd sensing is a paradigm that we use to collect the data. So here, as you can see, that mobile world is using, so that is nothing but that is related to the smartphones that each one of us is carrying, right? And the crowd means we are utilizing normal people to collect the data. And sensing is they must have some kind of sensors in order to collect the required data. So that is what mobile crowd sensing is, a paradigm where we utilize normal people's devices in order to collect the sensing data, right? So this is what the meaning of this mobile crowd sensing. Now, uh, what so what is generic IoT system? Let's say I'm a company, I'm an organization, and I want to collect, let's say, the temperature data. Just very simple example. I want to collect the temperature data all over India, right? So what I need to do, I need to, first thing, I need to deploy the sensors at different places, right? First in the city and then at the country level, right? So it is very difficult to deploy the sensors over the whole country like India, which is a very large in size, right? So, so in generic IoT system, what we do, we deploy the sensors and these sensors collect the data and send it to the cloud or whatever the organization, right? Cloud server. So this is what, how we collect the data. Now, what are the issues with the generic IoT system? One is data unavailability. Why I'm saying this data unavailability? Because like if I want to collect data all over the India, so I need to first deploy the sensors, which will give me a huge cost, right? And we need to setting up the infrastructure as well, so which will give me a huge cost. Another one is the maintenance cost. Who will maintain such huge network, right? So these first thing is this. So that is why we are calling it data unavailability. It is very difficult to collect the data from a large area. Another one is high quality services cannot be provided without having a large amount of data. And since if you are not able to collect the large amount of data, so that must affect the quality of service that you are providing based on that collected data. Another one is issue is data redundancy. So let's say there are two organizations or multiple organizations who wants to collect the same kind of data, right? So what they will do, they will deploy their own sensors, right? And even though their requirements are same, but still they have to deploy their own sensors and collect the data. So that's the data redundancy problem. So the solution of data unavailability is mobile crowdsensing. So it is not like that organizations are not using this approach. Organizations are using this approach very, I mean, you can say at a very large level. Like for example, Google Map, right? Google Map, what Google Map is doing? Google Map is collecting data from all people, right? Whoever uh, using their application, right? So what they are doing nothing but mobile crowdsensing, right? So organizations like Google solve the issue of data unavailability. So this is being done through the mobile crowdsensing, right? And the organizations, another way, what could be another way? Like I can crowdsource this sensing task with third party, right? But I need to ensure that that third party, okay, I will see later that, okay, I will crowdsource the sensing task to a third party for collecting the data. Because Google and Microsoft, they are very large companies. I mean, they use, uh, they can easily collect the data. But what about the short companies, or what about anyone? Let's say I'm a researcher and I need some kind of data. I need some temperature data or environmental data, let's say, right? So what should I? So in that case, this mobile crowd sensing may help me, or even this third point, I can crowdsource the sensing task to a third party, which will basically utilize this mobile crowd sensing approach in order to provide me the required data, right? And the application is like huge application of mobile crowd sensing. That could be environmental monitoring, public health, traffic data collection. So this is what the mobile crowd sensing. Here you have crowd sensing system. I'm not talking about centralized or decentralized. Just think is as a system. So here we have a crowd sensing system, right? Here we have a requester who needs the sensing data. And here we have data providers who will provide me the required data. So what I will do, I will send a request to this system, right? And this system will do something, and they will assign this task to these data providers. They will provide the data and I will provide the data to the requester. But there is something missing. First question is, why will people participate in such a system? Why they will use their own devices to collect the data for others without any kind of incentive or benefit, right? So that is why, that is one thing. Another one is curse of sensing issue. So what this issue is, this is defined as the inability of the system to control the sensing task. So let's say I want the temperature data of Pilani city in India, let's say from 100 people only, right? So why would I involve all Pilani people to collect the data for me, right? So somehow I need to control the sensing process. So this is the complete picture. So what requester will do? So in order to basically motivate people to participate in the system is like we are providing incentivization. So that could be in monetary form, that could be in like we'll say others benefits. So that we incorporate in this mobile crowd sensing system. So first, what the requester will do, requester will publish the sensing task and the reward mechanism over the crowd sensing system, right? Now, these people are registered over the crowd sensing system that they basically are here to help the people to collect data. So what this crowd sensing system, this will analyze the need of this requester and will recruit the participants. And it will ensure that the one who can collect the required data, they only participate in the system, right? So, and then this system will select some of them based on the requirement and will assign the task to them, right? Now they will use their own devices to collect the data and upload it to the crowd sensing system. And against their, you can say, the efforts that they have made, against those efforts, crowd sensing system will provide the incentive or rewards to the participants and based on the requester requirement, whatever this person was saying. And this system at the end will send the sensing report to the requester. So this is how a complete MCS system work, right? So now you will see, you will say that why do we need blockchain here, right? So this system could be handled centralized way, right? So these are the advantages, but so yeah. So we will see that what are the drawbacks of centralization later. So what are the MCS advantages here? It enables the involvement of normal people, right, to help the requester in order to collect the data. It makes IoT system infrastructure less. There is no need to set up an infrastructure in order to collect the data, right? Enhances the monitored coverage area. So people are residing in each city, right? We can utilize them to collect the data based on our requirement. And this is cost-effective solution because there is no need to set up the environment. There is no need to invest, like to deploy the sensors, to maintain it, right? So another issue was with the generic IoT system is data redundancy. So that we can solve if multiple requesters are having same basically requirement or same interest. So there is no need to create multiple tasks for multiple requests if the requirements are same. So for one people, I mean multiple people can subscribe to a single task so that there is we can solve the problem of data redundancy. So what are the MCS requirement? So first is data validation and verification. So how can we ensure that the data that is coming from the crowd is correct or not? Since there is incentivization mechanism is there, so people can basically try to get more benefits from this incentive mechanism, right? So that is why there is a need to first validate the data that is coming from the crowd. Second one is fairness. Fairness is required because data collectors and requester, right? What are the processes? First one is we have seen that first phase, one of the phases of MCS system is participants recruitment, selection, right? So that should, in this basically phase, we need some kind of fairness. It should not be like that there is a system which is selecting very few people, maybe they have some kind of collaboration with very few people. So the system selects every time to those selected candidates. So fairness is required at this process. Fairness is required at the time of data validation. So if I am saying data validation, so that means the benefits, the incentives will only be provided to those who have provided the correct data, right? So in that case, what so we will see the attacks what we could have here over the data validation, but it is need to ensure that data validation algorithm is correctly implemented and executed. And the third one is incentivizing user participation. So we need to ensure fairness in these processes. We need to ensure the privacy. We need to ensure the identity privacy, data privacy, and location privacy. So these three are required in mobile crowd sensing system. And the one handling cursor sensing issue that I do. Right. So these are the requirements that we need to ensure. Now, requirements to handle generic security issues like authentication is required, confidentiality is required because the requester is paying something for the data. So definitely that person wants some kind of confidentiality. Integrity is required and availability is required. Right. So these are some generic security issues that we have in mobile crowd sensing. Now, MCS specific security issues. So first one is we need to handle, there could be some malicious data collectors or there could be some selfish data collectors. Malicious are the one who provide wrong data intentionally in order to basically degrade the reputation of the system or the requester, right? And selfish in the sense is they want to earn more benefit out of the data they are collecting, right? So here I told you this and I told you this. So here the attack that is possible is Sybil attack. How Sybil attack is possible? Sybil attack is like they can create multiple identities and they can enter into the system with those identities. So what they will do, let's say I'm a data collector. I have created 10 identities and I use these identities in this system. So what I can do, I need to collect the data only once and I will send the same data with different identities, right? So that I make basically effort to collect the data only once and I am trying to get more benefits from this scenario, right? So this is how Sybil attack is very much possible. Free riding attack. So free riding attack, we can understand this from the Sybil attack only. Free riding is without making any effort, they want to earn the benefit, right? So the scenario that I gave you is very much suitable for free riding attack. Data collusive attack. Data collusive attack is like multiple data collectors can collaborate in order to provide the data. So that basically is required because of the data validation algorithm. And data poisoning attack is like they can change the data at any point of time. If they are able to do that, that means we need to ensure this. We need to prevent the system from data poisoning. Okay. And what could be the malicious intention of data requester? That is like that requester can do. Requester can reject the correct data as well, so that that requester should not basically will not give the incentive to the honest participants. So just to save the money. And along with this to save the money and to collect the correct data. Right. So that attack we called as false reporting attack. So there are two types. The type of MCS system could be like centralized and decentralized. So this is what the same, but here just assume that this system, crowd sensing system, is uh, handled by a single authority. Right? So you can consider it as a centralized server. So the issue is like data producer must rely on a single trusted authority. There could be trust deficit problem, right? A single point of the same that like that we have seen in the centralization. All these things are here. So we need to go to the blockchain in order to solve these problems. Right. So decentralization will ensure that there is no single authority. So it will create the trust among the parties. Right. And it is resilient against a single point of failure because of the distributed nature of blockchain. Right. DDoS attack and Sybil attack are handled at the network level. This is very important to understand that these attacks are prevented at the network level, at the blockchain level, right? But Sybil attack is also possible at the application level that we have already discussed, right? Now, next is threat of data modification. So that is, we can prevent this from the immutability property of the blockchain. We can ensure transparency, right, which will basically enhance the trust among the parties, and a risk of privacy closure that we can remove through identity privacy preservation that blockchain inherently provides because of the pseudonym identity. Right. So here we can use blockchain to ensure the trust among the parties. And this blockchain ensures the identity privacy. So the major issue with MCS system is the trust only. So that we can achieve through blockchain. Right. Okay. And now we are saying that inherently it provides identity privacy. So here I'm just trying to show the authentication process. Like here we have application. You can consider it as a browser. So you are submitting some data, and this is a button, submit button. So when you click on this submit button, user will click the submit button. So the transaction will go to basically the wallet, right? And this wallet is having a key pair. And this is what the blockchain address or pseudonym identity. So each pseudonym identity is associated with a public and private key pair. Even though this blockchain address is derived from the public key only, but you just understand it like each blockchain address is associated with a public and private key. So now this user will use one of the key in order to sign this transaction using this private key and will send it to the blockchain network. Now, in this blockchain network, any node can verify the authenticity of that person, right? Because of the this public and private key pair. So they use the public key and they can basically verify it. So we are saying that blockchain can provide trust and blockchain can provide identity privacy. But we have seen there are other requirements as well, like data privacy, right? And we need data privacy and we need to make the system cost effective, right? So is it, matlab, unlike if we use blockchain technology just to convert the centralized application into decentralized application? No, blockchain itself has several issues. Like first one is scalability. in terms of storage. Since we are talking about the data collection process, and this data could be very huge. And if this data is huge and we are storing that data over the blockchain itself, right? So this may create an issue of scalability. First problem. Second problem is data confidentiality. Whatever data we store over the blockchain, specifically public blockchain. So anybody can see that data, and this thing the requester will never want, because the requester is paying something for the collected data, right? So on-chain data privacy, like if we have to perform data validation over the blockchain, right? So we don't want to lose the data privacy while performing validation over the blockchain. So that is another issue. And the fourth one is on-chain cost. So in blockchain, whatever we do, if we try to change the blockchain state, then we have to pay something. So it incurs some cost whenever we make a transaction in order to change the state of the blockchain. Or at the application level, I can say if I add something, in my application, right? Or if I change something in my application, that it incurs some cost. And this cost is decided by the storage, how much storage I am using of blockchain, and how much computation I am performing in order to get something, right? So these are the issues with blockchain that we need to solve for this mobile crowd sensing system. So it is not sufficient to basically to come to the blockchain. So blockchain has itself certain limitations that we need to ensure. So the challenges with this blockchain based mobile crowd sensing system. So there is a trade-off in certain things like storing data on chain and performing on chain data validation. So if we do this, then we ensure trust, right? But there are certain issues with this scenario. First is data confidentiality we are losing. On-chain privacy we are losing. On-chain cost, it incurs a high cost, and scalability issue. Now consider the another scenario. We are storing data on-chain, but performing off-chain data validation. So it may basically help to reduce the on-chain cost because we are performing data validation outside the blockchain. But it will create trust issues, right? It will create trust issues. Another scenario, if we are storing encrypted data on-chain and performing on-chain data validation. So that means we are performing data validation over encrypted data. So in that case, we need to use homomorphic encryption because it allows us to perform computation over encrypted data, right? So in that way, we can achieve data confidentiality, we can achieve data privacy, we can achieve trust, but it incurs a very high cost because of the storage and computation and homomorphic properties. Homomorphic encryption. Right? Another scenario, if we are storing original data off-chain and performing on-chain data validation. So in that case, we are achieving scalability in terms of storage. We are ensuring trust. We are ensuring some kind of cost we can reduce, like storage cost we can reduce if we store the data off-chain, right? But there is a problem with data confidentiality, on-chain privacy, and on-chain cost with computation. Okay. Another scenario could be we are storing encrypted data off chain and performing on-chain data validation. So we can achieve several things, but still on-chain cost is there, right? Another scenario is storing encrypted data off-chain and performing off-chain data validation. So we can solve certain problems, but again, trust will be gone, right? Trust won't be there. So the challenges with a blockchain is like to mitigate Sybil attack at the application level. It is very difficult to forging blockchain identities because of the digital signature that we do. I mean, you can, you know my blockchain address, but in order to send any transaction using that address, you need my private key as well. So that is why it is difficult to blockchain identities, but it is very easy to create multiple identities. I mean, there is no restriction to create the blockchain identities. You can create as many as you want, which allows you to basically to launch Sybil attack at the application. That is another challenge. So there could be some possible mechanism like we can use detection over blockchain, but it may raise privacy concern definitely. If you use trusted third party, in order to basically mitigate this Sybil attack, you can achieve authenticity, but trust and user anonymity. So ultimate challenge in mobile blockchain-based mobile crowd sensing system is designing a secure, privacy-preserving, trustable, and cost-effective blockchain-based MCS system. So I am giving you a research problem that you can think of about it. Thank you. So this is what the theoretical perspective. So if we have time, I can basically, I would like to show some practical exposure of blockchain as well, specifically Ethereum blockchain.
And discussions and moderated by the chair, who is one of the doctoral supervisors.
Yes, we have time.
Okay, so
Oh.
we can go ahead with the implementation perspective. I'm using a Remix tool, that is web-based tool, in order to implement the smart contract and basically how the smart contract works. And so in blockchain, if you want to write some code, right? So each different blockchains use different programming languages, but I am talking about specifically about Ethereum. So in Ethereum blockchain, we use a programming language that we call Solidity, right? So, so what we need a blockchain, right? Over which we need to deploy our code, right? And whatever logic we have written in the code, we need to basically call those things, those functions, in order to basically upload the data or to fetch the data. So whatever you basically, if you want to add something, you want to add some values to the smart contract, so that data will go to the blockchain, right? But here what Remix does, Remix provides some, you can say, virtual environment of blockchain. So here you can see they use their virtual machines, right? So these are the simulated blockchains that we can use to check the logic of our smart contract. Okay. So I'm just giving you one example. So the extension of this Solidity file is .sol, right? So I have written here one simple bank code. So here in this code, we have functionality like we can deposit something and we can withdraw something. We can check the balance and we can transfer certain amount from one account to another account. right? So here the currency that I'm using is Ether. So the cryptocurrency that we have in Ethereum blockchain is Ether, right? So in Solidity, first thing is we need to specify the version that we are going to use using this keyword Pragma Solidity, and this is what the version of the Solidity, right? The way to start writing the code is we need to start with the keyword contract, and this is what the contract name, and whatever you write in your code that would be inside this contract only, right? So again, like we have the concept of programming languages are same, but the syntax would be different, right? So here in Solidity, whatever logic you have, you must basically implement those logic inside a function only. So structure is first you create contract, and then you declare certain variables, whatever required, and then the logic would be implemented inside a function. Function is a keyword, you write the function name, we will see the rest of the part, and then you implement the logic, right? You can see whatever function I have implemented. So here, whatever logic I have implemented is inside the function only. So mapping is a basically new data type that we have in Solidity. So mapping is nothing but a key value pair that here we have normal data types like integer we have, right, that we call it uint. That means unsigned integer, because in blockchain in Solidity, we don't handle the negative values. We only deal with the positive values. So that is why here we have uint, right? And the size of this uint by default is 256 bits, right? And here we have address. Address is another data type. So that is used to store the addresses. It could be your smart contract address. It could be your like identity blockchain address that I was talking about. Right? And so this is what we are creating a mapping between the address and the uint. I am making it private. So this is ensuring that nobody can call this. I mean, nobody can check the balance of basically of one another, right? So here I have created this mapping, and the address is what, like I am having one address and I am having some balance. So that mapping will ensure that in the same way for other user as well. So here address and owner. Owner is what? Owner is indicating the owner of this smart contract. And how we can set this owner? While deploying this smart contract, I can set the owner of this smart contract. Whoever is deploying that smart contract, that would be the owner of that one. And I am ensuring it using constructor. So under this constructor, I am storing the message.sender. So what is message.sender? Message is a global variable, and sender is a field in the transaction that we have. So I am fetching this, the address of the sender who is deploying this one, right? And from the transaction itself, I am storing that address into this owner variable. So for some time, you just forget about these events. So at this point, I have set the owner of this smart contract. And what are the functionality that we have of this simple bank is? First is I would like to deposit something, I would like to withdraw something, and I would like to transfer something, and I want to check the balance. So the functionality of this deposit function is like, so here we have modifiers like public, private, and internal. So public is what? Anybody can call this function. Private is what? That you won't be able to call this function. And internal is what? If you, you can call this function internally inside another function. Okay. So this is what the payable keyword. So since we are dealing with the cryptocurrency, we need to make it payable, right? And returns is a keyword. If this function is required to return something, so I need to declare here returns. And what kind of data you want to return, that the type of that data you will specify here. That means some integer value is returning by this function. Right. So this is what the logic. If I am depositing something, so my balance should be increased with the amount that I am depositing. So the amount to deposit, so I am using here message.value, which is a global variable. And I will show you that how can I provide the amount that I want to deposit. So that I am fetching using this message.value. And message.sender will tell you who is calling this particular function. Definitely who is calling this, that person wants to deposit something. So the deposited amount will be added in this mapping. Okay. And then emit is what the event that I have created here. So I'm emitting that event so that I can store the transaction in a separate way, in a log, right? And I am returning the balance. After adding this, it will show me that how much balance I have in my account. Withdraw means I want to withdraw something. So the amount, I need to specify the amount that I want to withdraw in this function parameter, right? Public is like visibility, return is a keyword. This is what the return type you want. So require is a way to check the condition in the smart contract. Right, so here I'm putting some condition that withdraw amount should be less than equal to the balance I have. So if this condition is not true, it will fail the transaction, right? If this condition is true, then I am subtracting the withdrawn amount from the balance and I am transferring. Transfer is a function, internal function of Solidity that I am using here to basically transfer the withdrawn amount to this basically address message.sender. Okay. And then I'm emitting this, I am returning the balance. If I want to check the balance, so here I'm just taking the balance from this mapping and can give it to you. If I want to transfer some amount from my account to some other account, so I have to specify the other person's address and the amount that I want to transfer. Here the return type is Boolean. I just want to check whether the transfer is successful or not. So here I need to check certain things like amount that I am trying to transfer that should be less than equal to balance. And the second person's address is not invalid. So that I am checking using address 0. So address 0 means invalid address. If I am putting this here invalid address, so it will not allow me to go ahead. Now I am deducting this amount from my balance. I am adding this amount to the receiver's balance. And then I am transferring the amount to this address too. And I'm emitting the event and I'm returning true. Okay. The Solidity is a very easy language. There is nothing much to do. Now we have written this smart contract. Now first thing is what? We need to compile it, right? So here we need to basically select the compiler that is basically you have set here the compiler version. You will select it here. and I have clicked it auto compile. So it will, whenever I write it, it automatically compiles. So it is, this green tick is saying that, okay, your contract is correct. Now you can go ahead with deployment. So in order to deploy it, what we need a blockchain network, right? Where this contract will go, right? So that Remix is providing a simulated blockchain network. So here we can select the environment. Now, second is we need the blockchain address, right? In order to communicate with this smart contract. So this Remix provides us a few addresses along with fake ethers. So these are the 100 ethers which are fake, right? We cannot use it on real blockchain, real Ethereum blockchain. And it is providing us like to specify the value of, or the amount that we want to transfer. So we can set it from here. And here you can see these are the units of the cryptocurrency. Way is the smallest unit of Ether, then Gigaway, then Fini, then Ether. So 1 Ether is equal to 10 to the power 18 Way. Okay. And here we need to select the contract name that we want to deploy. And here, once we click on this deploy, what would happen? It will create a transaction, right? It will be signed. It will be signed internally. This Remix tool is doing everything. It will sign it and it will send it to the simulated blockchain network. Let me click on this deploy button. You just notice here. Just see here. When I click on this deploy, here you can see this is what the transaction is. Here you can see the status is transaction mined and executed, execution succeed, right? That means there in the simulated network, some miners are there who mined this transaction and executed it. This is what the transaction hash. Each transaction is identified by a particular hash address. This is what the block hash. So because each transaction cannot be stored separately, so it will be residing in a block, right? So this is what the block address. And this is what the block number that we have in that simulated network. This is what the contract address. So when we deploy some contract, some address will be assigned to this particular smart contract. And this is what the address, right? Who has deployed it, that you will know from this from field. If you check here, this is what the same address. I deployed this smart contract using this address, and you can see here, right? 2, there is nothing one because we are not sending this smart contract to anyone, right? That is why here it is simply written simple bank.constructor. The amount of gas, so the cost that I talked about, that each transaction will cost you something if you're trying to change the blockchain state. So that will be decided based on the gas unit. So each operation that we perform in this smart contract, so each operation is associated with the gas unit, with some gas unit, and total operation that we performed here. So those is this much of gas that a smart contract has taken to deploy itself, right? So this is what this is the total cost. This is the transaction cost and execution cost. So ultimately the total gas cost that is you have to pay is this. And each gas unit is having some gas price. So that gas price is dynamic. So that will give you a complete cost in Ether, at how much Ether you have to pay, right? So here, this is what the output. This output, what is this? This is the byte code of your smart contract. Okay. And there is no input, there is no output, there is no log, and there is no log. So this is how a transaction looks like. And here you can see earlier, the balance of this contract was 100 Ether. So once you deployed this smart contract, some Ether is reduced from this amount. 100, right? Okay, once you deployed it, that means your smart contract is now available over the blockchain. Now these are the functions that you have implemented. So initially you deposit. So let me just show you. Just let me take another address. That means this is the first person. So currently I am checking the balance of this. It is 0. Here you can see one transaction is made once I click on this balance, right? So whatever you do, it will create a transaction. Now it depends whether it will cost you or not. Since here in this balance function, we are not changing any blockchain state. We are not changing any variable here. We are simply fetching something. So in order to fetch something from the blockchain or in order to read something from the blockchain, it doesn't incur any cost. Okay, so it will not cost you, but it will create a definitely, it will create a transaction. Okay. Okay, now I need to deposit something. So since I am picking the value using this message dot variable, so I need to specify here certain amount. Let's say I'm saying 100 V. 100 V I want to deposit in this smart contract. So I will click on this deposit. I have changed this balance mapping, right? That is why it is costing you. Screen tick. It will cost you something, right? And now if I check the balance, you can see here the balance is 100 now. Okay. Now, let's just withdraw something. Let me withdraw 50 V, right? I'm clicking on this and the transaction is successful. Now, if you will check the balance, so balance would be 50 only. Here you can see we have 50, right? Okay, now the third one is transfer function. So in order to transfer something, what I need to do, I need to first copy another address to whom I want to transfer. So two fields are required here. One is the address. So I'm pasting the another one address and the amount. How much amount I want to transfer. Let's say I'm saying 10 V. We just transfer 10 V. I'm clicking on this. Here you can see one transaction is made. And if you see the balance of this, you can see here 10 V has been added in this address, right? And now you will see the balances, it is found, right? So this is just a simple example that I have shown. And so it is very easy when you write some code, smart contract, you first check the functionality of a smart contract using Remix tool. It is very easy. So there are other network as well. What you can do here, we use simulated network that Remix provides. So there are public networks. Public network means Ethereum main network where everything will cost you. So you need real Ether. So definitely we won't do that. Next is test network. So there are some test networks available for Ethereum blockchain. But the issue is now they are in test network. We need some fake Ether, right? And in order to get those fake ether, we need to have some real ether. It is very unfortunate that earlier there are faucets that provides us fake ether. And now what faucets are doing, faucets are saying you must have some real ether in order to get fake ether. So that option will, if you want to invest, you want to have fake ether after having some real ether, you can do that. And the third one is simulated blockchain network. So one is implemented here that Remix provide. Another simulated network is Ganesh that you can use. Ganesh is a simulated blockchain network. You can use that one as well. But just to check you can say the logic of your smart contract, it is very easy to use Remix. Right. So I think I'm able to deliver something in blockchain. I don't know how I got successful to deliver some important points, but yeah, I'm done with this. If you anybody have any doubt, then I would be happy to take.
I think it was a great lecture.
Hello, hello. Am I audible?
Yes. Yes. Hello. Hello.
Yes, yeah, from
Yeah.
introduction blockchain to then mobile, how this new technology, mobile crowd sensing works, then implementation. It's really great for beginner level people. So I think it
Yes.
was a great lecture. Yeah.
Thank you. Thank you so much.
Hello, am I audible?
Yes.
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 Yeah, so you're talking about this fully homomorphic encryption.
Yeah.
Uh, so can we get some information about that, how it's work on the encrypted database or the encrypted data on in, yeah.
See, I mean, I haven't implemented it, but yeah, I mean, I have seen certain papers where they talked about that they performed computation over encrypted data in the smart contract. But definitely it needs some additional things like setting up the key, how the smart contract will have those keys, and in order to perform computation, definitely we need keys, right? So how the setup will be done and how the smart contract basically will perform computation over encrypted data, that we need to see.
Nice. Okay, thank you. And in this your demonstration of this
Yes.
Ethereum blockchain,
Yeah.
are we using any kind of consensus algorithm?
No, actually, we are working on at the application level, right? So
Yeah.
definitely the consensus algorithm must be using behind the scene, right?
Yeah.
The simulated network that we're talking about, the Remix is providing, right? So there
Yeah.
definitely consensus algorithm must be implemented.
Okay. Thank you. I used to work on the same thing, and I realized that sometimes it's using a high number of gas cost.
Yes, yes, yes.
So is it depend on the function we declare or the transaction on the?
No. Whatever logic you have implemented, I mean, you can reduce a certain cost by optimizing your code that you have written, right? Like for instance, I'm just taking an example. So there are different size of uint data type, right? You can use uint 8, you can use uint 16, and then you can use uint 256,
Okay.
right? So definitely 256 will take more cost.
Yeah.
So
Understood.
if your requirement is just to store let's say 1 to 100 numbers, then why to use UN 256?
Yes.
Yeah, so there are other ways as well to reduce this cost, but yeah, if you're performing computation over blockchain, definitely.
So okay, it was a nice lecture.
Thank you.
And yeah, I saw your profile, Google profile, like you're also working on this cryptography and blockchain and network security.
Yes, basically my PhD topic is this only, blockchain-based mobile crowd-sensing systems.
Oh, mobile crowdsourcing. So like one more thing, I'm getting like the review things that we have done for Amazon or any other these commercial websites can also be included in this crowdsourcing, because somehow we are giving them some kind of data by reviewing some products.
Definitely.